Hello, hi, my name is Shmaka Aniko. This is my semester summary. I've spent the past 16 weeks taking EEE 202, which is circuits, and this is going to be a summary and an overview of everything that we did throughout the semester. So we started out the semester talking about electrical and magnetic properties of matter. This was one of the first things that we went over. We actually ran a couple of experiments to essentially make sure that we understand what those properties are, how electricity flows, and the properties of a magnet that allow it to attract, how the like poles repel each other, whereas same poles attract. All of that is what we went over during the first couple of weeks. And then we went into cells and bulbs. In this section, we talked a lot about how you can actually light a bulb with essentially what you see here in this picture, just two wires, a battery, power source, and a light bulb. And we tried different configurations using long bulbs versus round bulbs and attaching them to differing amounts of power. And that was the next big thing that we covered. And as I mentioned, series and parallel that came into play again with the cells and bulbs, and we learned about how to wire a circuit in series versus parallel, and we used these little things, not this exact one, but very similar, the multimeter, to gauge the current throughout the circuit at varying points, and it was able to demonstrate in a real-world example how current differs as it flows through a long bulb versus a round bulb, for example. And then we went into simple circuit analysis. We would look over circuits and be able to determine, for example, having this amount of voltage flowing through the circuit and knowing that there's resistors here in series, in parallel, and so on, and being able to essentially calculate what that would be if you simplify each one to know exactly the resistance as the current is flowing, and being able to determine the current as it flows through each resistor. We spent a lot of time on Arduinos this semester. This was a big chunk of what we did. There was, I believe, 16 total experiments in the book, and we went over every single one. This one in particular I liked because it actually made each of these light up individually, so in succession. So it would be this one, then that one, then that one, so on and so forth. And this was all the work that we did with the Arduino, figuring out how to wire different things, was one of the most interesting and fun parts of class. We spent quite a bit of time on this semester. And this was project 1. We built the electrostatic polarity detector, and essentially this was a detector that's able to determine whether the material is positively charged or negatively charged, and it's supposed to emit a different light depending on the polarity of the object being brought close to it. And this was some of the supplies, us in the middle of our build, and us finally getting it to actually work, showing the red light here. Okay, we spent a lot of time, of course, on Ohm's law and Kirchhoff's law. these are some of the foundations of circuit analysis, and both of these work in combination with one another, and you're able to use these to simplify circuits and to understand how your current is flowing throughout a circuit, and how many, for example, how many ohms of resistance that you'll have in a particular location, how much resistance, but also how much current would be flowing in that same part of the circuit. And these are fundamental to circuit analysis, and we spent a lot of time on this as well. And fundamentals of electricity. This goes hand in hand with the electrical properties, and we spent some time talking about electricity and how it's generated, how it's used to power a circuit, and this was a little bit of what we did. During the semester, we would have lab practicals and interviews. So the lab practical was a way to be able to demonstrate essentially what we had been learning in class. We would have a certain amount of time to demonstrate a competency and work with the different skill sets that we were generating, whether it was with the Arduino or the circuit analysis, wiring things in parallel versus series, and so on and so forth. Okay, we spent a good chunk of time on capacitors, and this is actually an experiment that we did in class where we were able to measure the I believe it was current in the capacitor as it was charging and being discharged. And we can see, even here, you can kind of see in the graph how it would the energy would be able to flow and charge, and then you see it falling down as it discharges. And yeah, that was a cool little experiment that we did in class. And we learned, of course, about capacitors, which are able to hold charge, what role they play in a circuit, and what they do, so on and so forth. We talked about op-amp circuits. We went over just the basic configuration of these. We didn't spend too much time on this, but this was another interesting part of the semester. Raspberry Pi. We actually were able to get our Raspberry Pi to hold and play retro video games, which was really, really cool. I enjoyed being able to see kind of how basically bare bones a computer could get, which is exactly what this thing is. You're able, but still see that you're able to do something with it, even though it doesn't look like much, but even this thing here is able to accomplish a lot. That was really interesting. PSpice, we spent a little bit of time on PSpice. Essentially, this is a way to build and test circuits in a schematic format prior to building it. And this I thought was really cool. I'd already used a similar program in one of my past classes called Logisim, where you're able to simulate different circuits and then test them out, see how the components work together, whether it actually function before spending the time and energy and money into building it. So this I thought was really, really cool. And then Project 2. We were tasked with building lightsabers. This was very difficult. Even having all of the resources that we had, the wiring and the circuitry behind it is very complicated, and we just found that we had a pretty tough time trying to get this one to work. We we researched all that we can, and we tried to figure out how exactly to bring the components together to make it work. But this was a really good learning experience because it made us realize that planning is key in figuring out how to best put together a project. We talked about first and second order differentials, and differential equations are really interesting. You're able to basically relate rates to one another. So you can relate a second derivative to a first derivative in a function, and this is the example of the spring here, which studying first and second order differentials in math was really helpful because it made me realize how that the math relates to the real world and how we can actually apply these mathematical principles to problems that we'll see. Laplace. We went over Laplace very briefly. It's mostly consisting of just knowing that they're a way to simplify circuits, and it makes it much easier. And basically, Laplace is really great for electrical engineers. They're able to use the transformations in a way that allows them to build their circuits more easily. So Laplace was interesting. And towards the end, we learned a little bit about OneNote and using it and how the note-taking program works. It's actually really cool. You're able to have multiple notebooks, within those notebooks multiple files and sections. It's really great. While we were doing all of that and learning all of the things that I just mentioned each week, throughout this semester we were also required to participate in posting a neat resource, doing a weekly discussion, weekly summary, and also journaling and completing our portfolio notebooks. It was a lot of time spent on this class altogether. It was quite work intensive, but a really good learning experience because we did touch on so many things. Oh, this is just a video of, let's show that here. I just wanted to show that video because that was one of the coolest things. I think the Arduino is really powerful in how you can build so many things with such small components. In that video, and the light display and how we were able to program the LEDs to not only change colors but follow a certain sequence, I thought was really interesting. It's my favorite from this semester. So overall, I think I spent an average of around 8.5 hours each week on class, and for a total of about 136 hours on classwork for this semester was my best average. And I think that all of that information, all the work that's gone into this class, everything that I've done, studying, prepping, working on assignments and projects, and I definitely think I deserve my A. I've put in a lot of work. I feel like I have greater understanding of how circuits are composed and built, but more importantly, I feel like I have a greater knowledge of what resources are out there and available to me. I think that's one of those things. That's one of the biggest things that this class did actually, was just show that there's so much that we're able to, there's so much that's accessible to us if you're